Hello and welcome to the Omnex webinar, Ever-Changing Landscape of Automotive Cybersecurity, Will There Be a Limit? Today's presenter is Dr. Juan Pimentel. Dr. Juan is a principal consultant for cybersecurity for Omnex. Juan has extensive engineering, safety, cybersecurity experience prior to joining Omnex. He was a professor of electrical and computer engineering at Kettering University. His knowledge and experience includes applied research, product development, safety, and cybersecurity assessments and assurance. Juan has extensive experience in security and cybersecurity in operational technology and industrial control system environments that include oil and gas, petrochemical, and automotive. During this webinar, if you have any questions for Juan, please enter them in the Q&A box, and he will get to them to the best of his ability at the end of the webinar. This webinar is being recorded, and someone from Omnex will reach out to you with how best to access the recording sometime in 2 weeks after the webinar. All right, Juan, you can start sharing your screen and start the webinar.
Okay, thank you very much, Miles, for the introduction. So I'd like to see if you have my, you see my screen now?
I do not see your screen.
How about now?
No, nothing yet. Are you hitting the green share screen within the Zoom panel?
Yes, let me do it again. Let me try one more time, okay?
Looks like something's coming. I'm seeing the slides, but not in presentation view.
Do you see the first slide?
No, I see. There we go. Now it's loaded. There you go.
Do you see only one slide or two?
No, now you need to switch your display settings.
All right.
I see the presentation view.
Very good. Then welcome everybody to this webinar, and the topic.
No, Juan, you need to switch the settings. It's showing the double presentation view.
Oh, okay.
There you go.
Do you see only one or two now?
Nope, it's perfect.
All right. Again, welcome everybody to this webinar. And the topic, as you could see, is a very interesting topic. I called it the ever-changing landscape of automotive cybersecurity. Will there be a limit? So I think you already saw some of these slides as an introduction to Omnex. So I'm going to go through this fairly quickly. These are some slides talking about what the company is all about, the offices worldwide, and the markets that we work on. Okay. The main market that pertains to this webinar obviously is automotive, but as you can see here, there are actually several other markets that Omnex operates, like aerospace, semiconductor, medical devices, manufacturing. We provide a variety of services, safety and cybersecurity being one of them. The other one is quality oriented. I'm sure you have seen the brief bio, read my brief bio, as well as my colleague Kymal, who helped me prepare the slides. Unfortunately, he won't be here to help me out with the presentation. And this is the abstract. I'm pretty sure you read this. So I'm just going to jump over to the main topics. So this is the outline of my webinar. I'll provide you with some introductory remarks, and then talking about what are the main issues, particularly what I call a recurrent problem when implementing ISO 21434. I will also deal with some issues about complexity and also issues implementing this particular standard. And I will outline some possible solutions to this problem. All right, so I'm expecting that you have an overview, at least, of what ISO 21434 is. This standard has been developed for a while now and was published about a year and a half ago. And the current state of affairs is that most companies are familiar, at least, with the scope of the standard. And they're actually very busy in trying to figure out how to best implement this standard. So that's where we are today. To keep a long story short, there are many issues about implementing this standard. And the one that I'll be talking about today is correlated to the fact that we have a very complex vehicle environment. That is the main topic. What does that mean for implementing 21434? So that's another way to take a look at this particular webinar. So first of all, ISO 21434 is not the only standard that's applicable for automotive. And this figure is a little bit old, just to illustrate the fact that when I wasn't on the committee that developed the 21434, by the way, but when the committee was heavily working on it, there were already many documents and many standards pertaining to automotive, okay? And this diagram shows that. There were some standards, for instance, talking about TPM, which is Trusted Platform Modules, and even standards from an organization, so European organization called ITU, which stands for International Telecommunication Union. So the bottom line here is that there has been and there were many documents, many standards prior to the development of ISO 21434. Just briefly, again, this is not an overview of the standard. However, I need to go over some of the main things about this standard so that we come to the same level field. In other words, to have a common understanding, at least about what I will be assuming about 21434. So first of all, it is a framework for implementing cybersecurity at the vehicle level. And this framework provides several things. One of the main things that it talks about is tailoring, which means that you may deviate from the actual standard in terms of applying this standard, particularly in the usage of the so-called CALs, cybersecurity assurance levels. CAL is optional as opposed to the other measure of risk, which is called risk value. So unlike safety in cybersecurity, we have two measures of risk, and they are called the CAL and the risk value. Okay. So if you're familiar with safety, this is something a little bit similar, and yet the details are totally different. Okay. So this particular estimations of the risk provides requirements of validation confirmation measures to ensure a sufficient and acceptable level of cybersecurity being achieved by the standard itself. Here is a very high level overview of the structure of the standard itself. It's organized in clauses. There are 15 clauses altogether, as you could see here. The clauses in the middle ones are critical in the sense that they are the so-called life cycle phases, okay? You begin the development at the concept phase in clause 9. You move in the middle one, which is the bulk of the technical development, at the design, which is clause 10, and also at the validation, which is clause 11. And then you move to production and the other phases, the so-called post-development phases, which are clauses 12, 13, and 14. All of the other clauses, you could think of them as being helper clauses, some more, I guess, critical than other ones. For instance, 5 and 6 that deal with with the management aspects, management at the organizational level in 5, or at the product level in 6. Now, 7 and 8 talk about very important aspects of implementing this standard. 7 is how to deal with suppliers, called distributed activities. And 8 is very critical in that, unlike safety in security, we need to continue perform many activities that are directly related to the safety of the product, and it's called continual cybersecurity activities. And finally, down here, clause 15 talks about the main methods that we use for TARA. TARA is the threat analysis and risk assessment that is needed by clause 9. The next 2 slides, I know it's hard to read, but gives a bit details from the standard itself about these particular clauses that I just mentioned briefly. I circle stuff in red only to point out that in this webinar, I will be discussing some critical issues about this particular subsections of the clauses dealing with cybersecurity audit, component out of context, off-the-shelf components, cybersecurity case, and cybersecurity assessment. I just wanted to point out a few things related to these particular subsections of the clause. Here are the other clauses in a bit more detailed fashion in terms of the contents of the clause themselves. At the concept phase, as you could see, you have the so-called item definition, cybersecurity goals, and cybersecurity concept. Again, the stuff in red is directly pertaining to what I will be discussing in this particular webinar. And then, as you could see, you have the other subsections in a bit more detailed fashion here. Again, clause 15 here are basically the methods that the standard recommends to do the TARA, the so-called threat analysis and risk assessment. All right, let's begin with one of the major topics of this webinar, which I mentioned is about complexity. And I have here on the right side a figure that I think I detail later on. Okay, but this will be the first time that I'll talk about this particular figure. And what we're talking about here is that the 21434 standard begins with the so-called item definition, okay? So the item definition is similar to the one that is used in functional safety, not exactly the same, but similar. So here you have an item definition of a product that we work with some of our suppliers. Obviously, I hid some information that might be confidential. So this is a very generic diagram. So what we're talking about is a product called the TMS, and TMS stands for a thermal management system. This particular product is becoming very, very modern and contemporary and very useful and very critical for current designs. So as you could imagine, this module is used to cool off or heat up, depending upon the temperature, of course, elements of the vehicle. This element could be a battery, an electric battery, which is a good application. However, it could also be other things. For instance, it could be a what is called a domain controller. As you probably know, these controllers in automotive are becoming very complex. They're so complex that the computing power is so high that you need to cool them off, okay? And sometimes heat them up. So basically, the cooling portion is the most important, but there's also the heating portion. So here you have a high-level block diagram of some of the sensors and some of the blocks that are in this so-called thermal management system. As you could see, the stuff in the blue here indicates the flow of coolant, okay? And as you could see, the coolant goes through a pump or goes to a heater, goes to a chiller, which, you know, it's an exchange mechanism that will cool off the actual device. And the component to be cooled is at the vehicle level, at the vehicle, which is down below. And of course, you have interfaces within the vehicle and the other portions of what's inside the item. Okay, so the item is composed of the controller, the sensors, in this case, the chiller, the heater, and the pump. And external to the item is the element that is being cooled off, plus the other components of the vehicle, of course, that we're not concerned about. And here's the critical thing. We're finding out that there are elements in this item that are becoming very complex. I have two examples here, heater and the pump. They're complex in that it used to be that these elements were fairly simple, perhaps just a mechanical component and an electrical actuator, maybe a coil-operated switch, for instance. Today, that's not the case, unfortunately. These heaters and pump and stuff like that, they're highly sophisticated. They have additional sensors, they have computers, they have additional actuators, they have communication lines, most likely a CAN bus or something like that. So all of a sudden, these devices, components that used to be fairly simple just a few years ago, okay, today and in the future, they're becoming very complex. And that's part of the system. So we're dealing with a explosion of complexity. Not only the vehicle has become very complex, as you know, but these devices, which are part of items, if you follow the standard 21434 or 26262, are becoming extremely complex, okay? So the question is, then how do you assure security for each of these subsystems? And which also means, obviously, how do you assure security for the entire item? So it's not only the components, but the entire item, okay? And also, given this particular fact, how do you implement ISO 21434 for this particular item, for instance? So the complexity is really pretty high, and I will explain some of the issues about this as we move along. So I call this a recurrent problem because, as you know, Omnex, we work with many suppliers, and as we continue helping suppliers, we're beginning this problem to occur more often than not. This seems to be the rule, okay? So the supplier then, the typical problem is that it is tasked to develop a controller, okay, that includes implementation of ISO 21434, and this controller, unfortunately, and the reason I say unfortunately is because it's becoming complex, involves other subsystems that are very complex, okay? So then how do you approach implementation of 21434, right, in this context? And I am perhaps not listing all of the particular issues, only a few of the issues, but I'm just explaining that this issue is very complex because in some cases, the suppliers that are in charge of these components that are complex have not implemented ISO 21434. Also, these devices that are already available, commercially available, they have some security features, but they are not in the context of ISO 21434, they're more generic. So we have many issues correlated to the fact that the supplier is not involved in the implementation of 21434, okay? In the current implementation, in other words. So that's just one issue. The other issue is, of course, given this context, then how does this supplier performs or do an item definition? How does the supplier perform the analysis for cybersecurity? Obviously, to meet all of the requirements. And along with this analysis, I'm pointing out here some what I call critical work products this is from 21434, dealing with a cybersecurity audit, dealing with a cybersecurity case, or with the assessment. And also there's some management aspects, meaning that this supplier needs to communicate, needs to deal with these other suppliers they need to work together, obviously, in order to meet all of the requirements for cybersecurity. And finally, of course, how do you manage all of this complexity that I was telling you about? The complexity is not just technical, by the way. The complexity is also organizational, if you think about it, from the management standpoint, because all of a sudden you need to get these other suppliers involved in the assurance of the cybersecurity of the product. And then, of course, there are a few other issues. I'm not trying to be totally exhaustive here. I am simply bringing up this problem and talk about the most important issues, because to my knowledge, the industry has not recognized this problem, at least not explicitly, not formally. I'm sure many companies are aware of this, many suppliers are aware of this, OEMs are aware of this, but I'm talking about in terms of standards, in terms of documentation or addressing this issue. I don't believe it has been addressed in a very organized fashion, if you will. All right, so going over the additional explanation of what this problem is, I talk about here that in the context of the V model, we need to analyze the flow down, what is so-called the flow down of requirements. And I'll explain this in the next diagram real quick. So the issue of requirements is very important, because at the end of the day, you have a bunch of requirements, and it is not just the OEM or one particular supplier that is in charge of all of the requirements. It is a shared responsibility. That's the main thing. Also, some of the requirements could be fulfilled by the so-called off-the-shelf components. I'll talk about this a little bit, okay? That is commercially available at the time the security design is performed. Also, the supplier of this component must provide some documentation that will help the higher layer supplier or the OEM to really ensure that the safety is assured for that particular product. Okay. And I say that this problem could be made worse if the off-the-shelf component has not implemented all of this required cybersecurity controls. And typically this is becoming the case, maybe some new vulnerabilities are being discovered. Okay. And the point I made earlier is that unlike safety, there's a big difference between safety and security in this context. We have in security, we have vulnerabilities that are continually being discovered. That's a big issue, really big issue. The standard 21434 has a process and a recommendation on how to deal with this. However, it's not just having a process or recommendation. I think the issue I'm talking about is actually doing it. It's really much more complex than it seems to be. Here is the left side of the V model. That is, the V model, by the way, is not explicitly outlined in 21434. It is implicitly assumed that you can use or you will use the V model or something similar. And users or implementers are typically referred to the standards such as 26262 that describes the V model in much more detail. So here on the left side, I only have the left side of the V model. I'm not going to be discussing topics on the right side, so I'm just showing the left side of the model. And as you know, many aspects on the V model, one of them is the requirements, and that's what I'm emphasizing here. So you have three boxes in green here, meaning that I am looking at the requirements, and you start off on the left side, top level, at a very high level. And then you derive requirements from high level requirements. At Omnex, we call that process a flow down of requirements, okay? So you flow down, meaning that you derive more detailed requirements moving down, okay, from higher level requirements. And then we have what is called right here the lower level security requirements. You keep the flowing down of the same process, and eventually you need to implement these requirements in the components. You know, that's where the critical portion is, the implementation of that, but also the flowing down. And in this implementation, we have identified a bunch of issues, which is explained on the right side of this slide. For instance, the component supplier is not participating in the implementation of the standard. And this is happening more often than not. What that means is that the supplier may have chosen a component that has been developed prior to the implementation, that's already available. Another one is that this component has only generic security features implemented. However, they have not implemented 21434 explicitly. Another issue is that with the fact that we're finding more and more that this component supplier has incomplete security information that needs to be shared. In other words, we're finding that suppliers are talking to one another, of course, and they're asking for, hey, what kind of security information do you have? And that information is hard to come by. I'm not saying that it does not exist. Sometimes it does exist, but it's difficult to locate it. It's difficult to locate the expert, or it's even too difficult to locate exactly the kind of information that is needed. Sometimes the supplier provides information that is unfortunately not corresponding to this particular component, maybe other components or other topics. So we're finding issues regarding that location of that particular piece of information. Another one is that it is very likely that vulnerabilities will be found in this component in the future. And we need to obviously plan ahead of time in the future. It is difficult because it is difficult to find, for instance, the correct owner of that particular component moving forward into the life cycle. Okay. So some of these are management aspects. Some of these are correlated to the technical aspects. And the third one is correlated to the fact that it's just the complexity has increased. So everything we do is not as simple as it used to be in the past. Okay. And the last issue is about the fact that this component has some generic security features. Okay. However, the ISO standard 21434 has actually not been implemented. So as you could see, some of these issues are basically assumed that you are using what is called an off-the-shelf component, which is happening more and more. There are some advantages and disadvantages to using an off-the-shelf component, okay? So let's talk about when the supplier that we're talking about is implementing the item, defining the item actually, right? So the standard defines the item, by the way, as a component of subcomponents that implement a function at the vehicle level. And the crucial wording here is that it has to be at the vehicle level. If it's not at the vehicle level, then we're not talking about an item, we're talking about a component. So this is why sometimes you need to develop items which are called out of context. So one solution to this problem is to define the item as a COOC. But even this one sometimes is not enough, okay? Because we're talking about components that's very difficult to associate with a vehicle level. It's kind of removed. I guess the heater is a good example. Whereas the item, for instance, being a thermal management system, you could quickly associate it to a vehicle level because you are cooling off a component of the vehicle. But if we're talking about a pump, for instance, you could be pumping air, obviously, mostly air, or pumping liquid coolant, okay? And that is typically removed from the vehicle level. So you have to make additional assumptions to correlate it to the vehicle level, which means that it is not very obvious or straightforward to define an item here. So basically you have two choices. One is to define it as to define the item, but treat it as a component out of context. And the other choice would be to work with the item, with the product, as a off-the-shelf component. Either way, you still have to deal with the assurance of the security in the context of the higher level item that it belongs to. Going back to this item that we talked about that I'm using as a primary example, which is the TMS controller, okay? So one of the design decisions that you could make is actually, it's a good decision, is to consider this TMS as a component out of context, COOC. However, what about the components? I'm talking about the heater and the pump. It is possible that you could actually define them as a COOC as well, but particularly at Omnex, we're not recommending that. We're recommending that you treat them as a off-the-shelf component, okay? However, that is a generic recommendation. In few cases, it may be that you're better off defining it also as a COOC. The decision is not very straightforward because it also depends on whether or not the manufacturer of this pump and heater, for instance, are interested in implementing 21434 or not. You know, that's another issue. So regarding these components, then we have questions here. For instance, has the ISO 21434 been implemented, yes or no? We're finding that in many cases, the answer is no. The other one is, what are the threat models and assumptions? That's very important because 21434, as you know, it has a very specific threat model and a very specific way to do risk assessment, and maybe incompatible. I shouldn't say incompatible, but quite a bit different, I would say, quite a bit different than if you use other security standards, okay? Are there a list of vulnerabilities that are known, for instance, or what kind of testing have they undergone? Is there any sufficient security information available about these components that one can share? Also, what kind of work products are available? Particularly, if you're implementing 21434, I think I'm assuming that you know that these particular three work products are very crucial. The cybersecurity audit, the case, and the assessment. If you're not implementing 21434, these particular issues nevertheless become important, but in a more fundamental fashion, if you will. So the audit has to do with auditing the company, basically. The case is you're building up your case to ensure or to demonstrate that your product is secure. And the assessment is a final judgment, if you will, that somebody has to make to determine whether or not the product is indeed secure, you know. So all of that, of course, is very well explained in 21434. But if you do not adopt this, the truth of the matter is that if you're using a component that has not implemented 21434, then that component manufacturer needs to supply information that will help you with your audit, case, and assessment. That's just the bottom line. And here is one area where we found that the CIA, which stands for Cybersecurity Interface Agreement, becomes important and will help you answering some of these questions, and also dealing with the complexity that we're talking about. Again, this is not a class of 21434, just to refresh your memory. They use tables called the RASIC tables. And as you could see, here is an agreement that is implemented between a supplier and the customer based upon elements of the cybersecurity plan. This, obviously, this table is an example, is by no way comprehensive. Just to give you an example, so you go to your plan, and from your plan, you pick out certain work products or activities, and you lay out here who's responsible in terms of the supplier and the customer. And also there is a level of confidentiality here of the information that you need to share. Excuse me. So each one of these activities or work products are discussed here in the terms of the so-called RASIC, right? RASIC stands for this RASIC, meaning which party is responsible for this particular activity, which party approves the activity or the work product, which party supports the development of it, which party needs to be informed about it or consulted about it. So we found that this particular template is useful, it's good. The template exists. It's a requirement from 21434 that organizations do this. That is not the issue that we have found. The issue that we're finding is having an agreement and also the sharing of this information. You need processes to do that, of course. And you have some of the issues I pointed out before is locating this information sometimes is not very straightforward. By the way, this particular process or this particular setup is very easy to do if the product is totally new, all the components are new, and everybody is participating in implementing the standard from scratch. Then the issues are much simpler. The issue I'm talking about is when some of the components are off-the-shelf components that has already been designed prior to implementing 21434. Again, I mentioned that there are some management aspects, and here are a short list about these aspects. Perhaps the main point here to emphasize is the last one, the last bullet point. It says, how do you share processes and procedures in a multi-supplier environment? We're finding out that conceptually, this is simple, of course. I think everybody understands this. I think the issue is actually making it work, okay? Implementing it in a way that is efficient, in a way that it's also timely, because this takes time and effort. Just locating people, identifying what to share, what to not to share, that has become a problem in itself. Again, I'm not trying to be super comprehensive about this. In this webinar, I'm simply bringing out issues that we're finding out. And I hope that it is echoing in some of you. And hopefully you will be asking me some questions about it. And perhaps you're aware of some of these issues already. In this webinar, I'm not describing a solution. The solution is very difficult, by the way. I'm only describing maybe elements that might help in the solution. That's as far as I can go. However, I must say that at Omnex, in fact, I am doing research and we already found some solutions about this issue, but I'm not going to discuss them at this particular webinar, okay? This webinar is not about research and development. This webinar is simply pointing out the issues that we have found and maybe some ideas towards the solution to these issues, okay? So these issues, some of them are repeated, I'm emphasizing them, some of them are new. For instance, does each component need to implement ISO 21434? I like to hear your opinion about that. Again, it's becoming obvious that implementing 21434 is not trivial, it's very challenging, and it is very costly. So we would like to find a solution to this issue so that, you know, the implementation is streamlined, it's simplified, and becomes also less costly. If 21434 is not implemented, then what kind of security should the components have, for instance? The obvious answer for this is whatever they need to have in order to meet the requirements that come from a higher level. However, that's easier said than done. The other issue is that how does a supplier share this information? This third one, actually fourth one, by the way, this is very critical, we found out. And to our knowledge, the industry does not have a way to do this, okay? There is a solution to this problem called TISAX. I'll mention a little bit in the next few slides, but TISAX does not work at this level. TISAX is at the higher level. So we would love to have a solution similar to TISAX that will work at the level that I'm talking about. Another one is how to define an item. I mentioned that before, where the components are complex. Again, how do you handle efficiently the audits, the cases, the assessments in a multi-supplier environment? So that's a critical issue. Again, the sharing of this security information has become an issue. The question here is multifaceted, is what to share, when to share, and how to share. Another one is this sharing effective, in your opinion, the way it's being done today? Okay. In addition to that, we have a bunch of processes that are required to do that. And the question is whether or not these processes are well-defined and also effective. And I'm going to point out some directions of the solutions. Again, in this webinar, I'm not claiming that we have a solution for you, okay? We're working towards one, and this solution is very difficult. I mean, this problem is very difficult, by the way. However, we are talking about some elements of the solution, okay? So the elements of the solution are basically treating these components as COOC, sorry about that, or as a off-the-shelf components. Another element is we would like to have something similar to TISAX, but for product development. TISAX is mostly at the higher level. So we like to have something similar at a lower level. Again, we need to have solutions that will enable us to share not only processes, but mitigation strategies. And also, well, again, there are many issues that have not been addressed, but that's for later. And as I mentioned before, Omnex is currently researching some solutions that we will share later on when we finish our research. Okay, so I already pointed out and discussed the top issues. I have still several slides, but those are mostly complementary slides that I'm going to go fairly quickly. And the reason is that just to show you that we have thought about this at Omnex hard. And our position is that the implementation of security happens at several levels, at ODMs, tier 1s, and tier 2s. And the implementation is not the same. So first you need to position yourself, who are you? And in order to answer the question as to what kind of requirements are you responsible for addressing, okay? And this table, for instance, has some considerations about implementing these requirements, whether or not you are an OEM, or you are a tier 1 or a tier 2 company. I talked about the component out of context, which is very important. So if you adopt that solution, then here are some considerations to take into account whether or not you are a OEM, a tier 1 or a tier 2 company. Again, we have many documents and frameworks, if you will, in addition to 21434. We're talking about a regulation such as WP.29, regulations 155 and 156, the SAE J3101, which is for hardware cybersecurity, 3338, which is for OBD2, OWASP, which is for backend, for the cloud, if you will. ASPICE for cybersecurity, which is another standard that some companies are implementing today. And then there is this ISO standard for software updates. Again, I put in context 21434, just laying out the main features of it, you know. Again, this is something that I'm assuming that you already know, okay, in terms of this particular webinar, pointing out some of the features, but also pointing out some of the not drawbacks, but the limitations. One of the main limitations of 21434 is that it deals with inside the vehicle perimeter. So it does not deal with things like the cloud or backend servers or stuff like that. Another limitation is that it does not prescribe very specific technological solutions. In other words, it tells you what to do, but how to do it is a different matter. Okay, so in other words, this is why we say that 21434 is an umbrella standard that needs to be supplemented by additional standards, like I've been mentioning before, and some of them are listed here. Okay. And all of these, perhaps with the exception of the first one, are referenced in the standard itself, 21434. So the standard makes reference to these documentations. Again, at the networking side, you have additional standards supporting the cybersecurity activities. For instance, 26262 that I mentioned before, ISO 9000 series, which is the quality standards. NIST has SP, Special Publication 800, has a list of requirements as well as cybersecurity controls for systems similar to automotive. Even much older standards like this IEC 62443, this is a very old standards, about 15, 20 years old actually, dealing with cybersecurity, but this is more at the process level. That includes automation, by the way. All right. Again, the differences of the appropriateness about these standards, whether or not you are an OEM, tier 1 and tier 2, bottom line is not the same, as you could see. If you're on tier 2, you're more concerned about different documents than if you're an OEM. Here again is a link to other documents as it correlates to this important regulation from the European community called WP.29, which is becoming very important, by the way. This one talks about a sample of requirements to indicate the fact that if you're an OEM, you're interested in implementing some of these requirements. If you're a tier 1 with a different set, tier 2 still with a different set. Obviously, there is some commonality, so this table is not like black and white. And this goes along with this figure right here. All right, I mentioned TISAX. TISAX stands for Trusted Information Security Assessment Exchange. And what it is it's not a standard, it's not even a document. It is a forum for exchanging information about security, which is very important. So you sign up in a website, and then you and your partners exchange information about security. However, the TISAX is mostly at a high level. It is not very low level at the product level. And the kind of information that you could share is similar to this one, okay? Even trade secrets, financials, IP, of course, about the design of the product. So very high level. However, we would love to see something like TISAX for sharing information about assuring the safety and security of a specific product, for instance. All right, So with that, I'm going to just go to my concluding slide here, pointing out the main things that I have presented. And hopefully you have written some question and answers in the chat window. First of all, there's some challenging aspects in implementing 21434, and beyond that, dealing with the definition of the item in the complex environment, right? How to do the analysis of the security has become very difficult. And how do you actually produce not only these work products, but share information about these work products among other suppliers, including some other management aspects. So all of this is in the context of a multi-supplier environment in a very complex vehicle system. All right, so this is what the bullet point is talk about. We talked about some aspects of the solution, mentioning that you could approach the design from the component out of context point of view or off-the-shelf component point of view. Both have some pros and cons. We discussed that much of these issues are in the context of implementing 21434 in a supply chain environment. Okay. We see that CIA is very important. Okay, but however, implementing CIA is not so trivial. Okay, fortunately, this is well documented in 21434. I'm talking about what it is. The issue is not what it is, but how to actually do it efficiently. We talked about TISACs, which is very important. However, we would love to see something similar for products. Okay, at the current level, TISACs is not directly related to a product development. Rather, you know, the whole information security environment for the entire companies. We have identified issues relating to the sharing of these processes, not only information, but sharing processes and sharing mitigation strategies is also very important, which could be part of this new thing similar to TISACs that we're talking about. So with that, I guess a very good stopping point here. We still have time for addressing some of the questions. So with that, I would like to thank you for your participation. In the next few slides that you see in the presentation is additional information that you could get from the Omnex website in terms of additional courses that we have related to this topic. Courses on cybersecurity, of course, courses on TISACs, as you could see, courses on 21434 and SOTIF, courses on functional safety. So we have a complete curriculum in terms of functional safety and cybersecurity at Omnex that we would like you to invite you and go to the website and find out more information about this, okay? Or contact Omnex at this particular email and phone number. All right, so with that, then I like to stop and see whether or not we have had some questions. So, Miles, do you have a list of questions or?
Yeah, I am not seeing any questions in the Q&A box.
Oh, no questions. Can they ask questions online?
Yeah, there is.
Live questions?
Yes, they can ask questions in the Q&A box. But there are none posted.
Yeah, we'll wait for a couple of minutes. If not, I think we will close the webinar. We're at a good stopping points.
We just have one question asking if the presentation is available, and I can answer that one. Yes, it will be available. It'll be available on the Omnex website. We will have some people reaching out to the attendees with how to access the recording and the slides. So just wait to hear back from someone from Omnex. It's usually within a week or two we get it posted and edited down. So just look for emails from Omnex. I am not seeing any other questions.
Oh, okay. Great. Well, I don't know what that means. That could mean either that all the topics were perfectly explained, or perhaps the audience doesn't have too much experience in this area. They want to ask any questions. Oh, okay. Here I have one question. Sorry, I spoke too soon. The question is, it says, regarding the development of the COOC, which is the component out of context, okay, does the management activities rely mostly on tier ones? That is a great question. The answer is not related to tier ones, but okay, let me explain what the component out of context means, actually. It means that you need to make an assumption, right? And the answer is really who is making those assumptions. So that is the answer to the question. Sometimes, by the way, it is the supplier that decides that, and sometimes it's a tier one, and sometimes it's a joint thing. And this is something that we recommend that you clarify in the CIA, CIA, Cybersecurity Interface Agreement. That's the agreement between the organizations, okay? Very important question, and this needs to be clarified, obviously. Okay, any other question? We still have some time for one more question. I guess as a follow-up to that, let me answer the same question, assuming that instead of COOC, we could replace that by an off-the-shelf component. And my answer actually is similar, except of course that the details are different in terms of the off-the-shelf component. What it means, by the way, is that a company is using a excuse me, a computer, for instance, that was developed without 21434 in mind. They have developed this computer with disregarding this standard. There are two choices, actually, not choices, but two options. One is that computer may have some security features, or may not have any security features. And you have to consider each one in case. So at the end of the day, you need to do an analysis of that component and see how much information you need from the supplier and how much additional development you need to do to assure the security of the item. So bottom line is that you need to do a fair amount of analysis on that component. Obviously, the analysis is simpler if you have more, if the manufacturer of that component has done prior work on the security, all the way from maybe doing nothing, okay? If the manufacturer has done nothing, that means that the analysis has to be done more complete, okay? So with that, then I'm going to close the seminar. Thank you for your attendance and your questions. And hopefully I'll see you at another webinar from Omnex. So with that, goodbye. Thank you.
Thank you.